Hello everyone. Today we are going to learn a new concept that is involving friction block and block experiment. In this experiment and in this problem, we are going to learn that how friction is involved in two systems. Earlier we have studied that how it is involved in ground being static and the block being in motion. But if you kept a block over a block, then both of them would be in relative motion to each other. Friction acts as a relative motion between the two systems. So we are going to see an experiment in our virtual platform called Algodo, and we are going to see that how this friction is acting when we are going to apply a force that is going to move the block in forward direction, and how much force is actually required to move the block together till maximum distance, and at what force maximum the block will recede itself and fall back. So in this experiment we can see that there are two blocks involving this system. One is the block, and we can see the mass of this block is being 10 kg, and another block we can see it's a 5 kg block, you can see. So I'm going to apply force in this direction. Let's say we reduce the force to very small value, and at certain value we start the system. So we can see that both the systems are moving together, right? So now if we can try to follow this thing, and we see that how much force is actually required to make the upper block fall back. How much force is required to make the upper block fall back? We are going to increase the force slowly. You see it is moving. So with respect to any object you can see it is moving, and we can stop it. And how much force actually required to make the block fall back? We can increase the force to certain level, and we can see that slowly the block is falling back. So we are going to evaluate this force, the value of this force with respect to the values that are given, mass of the bigger block that is 10 kg and the smaller block that is 5 kg, and we are going to evaluate that what maximum force is actually required to keep these two blocks moving simultaneously. So let's see. So here we are going to understand the block over block experiment. So we can consider one block of 5 kg mass over another block of 10 kg mass. We can take the ground, and we have taken the coefficient of friction between the 5 kg mass and the 10 kg mass as to be mu is equal to 0.2, and this mu is equal to 0. So there would be a system in which F is small and M1 will take M2 with it. So there is an external force F that should be acting on it. So we are going to place an external force F on the lower. So let's say this be mass of MA and this be mass of MB for now. The question is that how much F should we exert on the lower block such that they move. So for the first case we can say that the block on 5 kg mass, there is this normal reaction over the second block. So this is M2 and M2G will act downward, and normal, let's say this one N for the first case, and for the bigger blocks 10, so it's M1. And so we have drawn the free body diagrams of two blocks separately, and for the ground we are not considering as we are not required it for now. So N2, that is normal reaction, is M1 M2G, and for N1 is equal to M1, but N1 has the weight of upper block also because M2 is over M1. So we can say that it's M1 plus Mg. So first rule to solve this kind of problem is that the first rule would be to find F limiting on both the surface. What is F limiting? F limiting would be the limiting friction that is acting on. So where will be the F limiting act? So to do that we have to search the block that only have frictional forces. So this is the between first and the second block, that is MA and MB, in which we have the frictional forces. And the third is to find A max, that is acceleration, that is maximum acceleration for together motion. So using the first step we can solve it like this, that F limiting would be equal to mu times of N, and from the blocks we know, as we can make it again, that mu is standing between 0.2, right, for the 5 kg block, and N would be which one? N would be the N2 one, that is on 5 kg, right? So that will account to 0.2 times of 5 times of the 10, that will 10. So F limiting will come out to be 10 Newton, right? So where will this act? This will act in which direction? So when you are putting force, when you are exerting force in this direction, force MA on MB. So friction on, so the friction exerted on B due to A is in which direction? If you can guess, this block is moving forward, okay? So this will try to pull this block in this direction, okay? So friction exerted by on B due to A would be in forward direction, and friction is in account of relative motion. So there is a relative motion between these two blocks. So this block is also moving. So this block will tend to move in this direction, and it will try to pull the lower block, that is MA, in its own direction. So friction that is exerted on A due to B means mass B is now trying to pull this block towards itself, because it is going in forward direction in account of relative motion, will be in backward direction. So another force is on mass B on A, that is in backward direction, that is in point of contact between the two surfaces. So this is FB due to A, and this is FA. Well, these forces do not cancel out because they are acting on different bodies in account of the Newton's law. So further solving this equation, we now get the limiting value as 10 Newton. So we now get the limiting value as 10 Newton. So now we can calculate the second part, the second step, in which we can calculate that in which body the friction acts. So using the F max calculation, so the acceleration on the block would be on block A, right? We want to calculate the acceleration due to other body. So use maximum acceleration in other block, okay? So how will you calculate for maximum acceleration? So due to this 5 kg blocks, the acceleration maximum is actually 10 Newton of F limiting divided by the 5 kg mass, which will come out to be 2 meters per second square. So this acceleration that is at max is actually 2 meters per second square in which direction? In forward direction. So let's make the block again. So this will act in forward direction. So this force and this acceleration value would be in second square forward. What is limiting this would be the F limiting downward, which is equal to 0. So basically this force is limiting this 10 Newton. So now if you want to calibrate it, you can just write the equation F minus 10, that is F limiting, is equal to mass times of acceleration. The mass of this block is 10 kg and acceleration is 2 meters per second square. So mass 10 multiplied. So this is F is equal to 20 plus F max results 30. This is what the maximum force that you can push so that both the blocks should move together. This actually calibrate between 0 less than 0 between F max less than equal to 30. So this is the limit we get. So F max is between 0 to 30. So now we are going to see this in the experiment of our virtual platform call, and we are going to calibrate it, and with the help of experiment we are going to understand that how we can make these two blocks move together. Is it possible in reality, or just we are going to match our theoretical results with our practical verification. So let's go. So we have seen that these two blocks comes out to be a maximum limited friction. So the limiting friction with the ground and this bigger block is actually 0, and because mu is 0, and we have taken the friction between this block and the block of mass A and block of mass B as friction value as 0.2. So when this block is moving, you can see that there is a friction force that is directing in this block in the reverse direction when it will be moving with respect to the another block. So first we have evaluated that the maximum force that came out is 30 Newton. So let's see at the smaller value how much it's going to be. So I'm going to just start the motion. So we can see that it is moving, but it is not receding. So let's see without following it. So we can attach a reference frame. I can try to follow it from larger distance. See, 1, 2, 3, start. So both the blocks are moving together. So this is a very little force in which we can apply to the lower block and the block moves together. Let's try to increase the force slowly. So our value as calculated stands between 0, greater than 0 and less than equal to 30. So let's see what happens at 20 Newton. Does the upper block falls back? So no, the upper block is still moving forward in the screen, and you can see. Okay, let's try to increase the force further, and 25. Let's see what happens. Still we can see that both the blocks are moving forward together. Okay, let's move it further and to our limiting value of 30 Newton. So we will see that this is the maximum force at which you can apply, so that both the blocks are moving together. In this you can see, and slowly there would be slight receding in this case because it's a maximum. Now beyond 30 Newton, if we increase, let's say 35, you will see that this upper block should fall back, as there, see, this is the largest frictional force that has been applied to keep this system stable. Now friction force is not dominating between these two blocks. Now the force that is external one, the external force will be dominating, and it is going to move the lower block forward, and the upper block will be not able to adjust with the friction force, and it should fall back due to the motion of the lower. See, so as it topple down, move forward. So this is an experiment that can easily explains that how friction force actually helps to keep the system together till the external force is adjusting with the limiting friction. After a certain value, the friction force dominates, and if you increase it any further, it will not give even time for the upper block to settle down. It falls due to its own inertia. So 0 to less than equal to 30 is the limiting value in which you can settle for the external force here.